So, hello everyone, I welcome you all again to the lecture 3 part 1 of communication systems. I am Sameer Lavankar. So, let us begin. So, a course outline for the last two lectures. So, we started with introduction chapter that was related to what is communication system, why there is a need for communication systems, how it is being evolved in the last 300 years from going to the drummers in the Akbar era to the World Wide Web developed by Tim Berners-Lee today. And now the social media has boomed us, and we have Instagram, we have Facebook, and all different types of social media sites for easy communication between point A to point B. Then next is lesson number 2, that was elements of communication system. In this we studied about three major elements of communication system, that was transmitter, then there was a channel, then there was a receiver. So, transmitter is the main part from which the source of information gets transmitted into it. If there is a non-electric signal, it gets converted into electrical signal using transducer. Then through a channel, either wired or wireless, the passage of information happens, and finally at the receiver, it retrieves the information, converts it again to usable form. For example, if it is an electrical signal, it converts into non-electric signal like voice signal, and hence then it is a receiver, and then finally the source of information is completed, and then it can be used for your various purposes. Next is the lesson number 3, that is basic terminology used in electronic communication system. In this we studied about transducers, we studied about what is a signal. There are two types of signals, one is analog signal, one is digital signal. Then we studied about different aspects of digital signal, then we studied about noise, then we studied about amplitude, then we studied about amplification, then we studied about attenuation. What is attenuation? Attenuation is basically the loss of strength with the passage of communication, with the passage of signal. Loss of strength is also analogous to loss in the amplitude. What is an amplitude? Just to iterate to you again. So, amplitude is, let us say if this is the sinusoidal wave which is passing, let us say it is a function of time, and let us say the y axis is voltage. Then if the attenuation has happened, that means there is a decrease in the amplitude. There is a decrease in the amplitude. So, just for informative purposes, this is amplitude being shown here, let I denote it by capital A, and then after attenuation this is the new capital A, let us say I denote it by A dash. So, because there is a decrease in the amplitude, hence there is a decrease in the strength, and hence attenuation has happened. But for more efficiency, for more passage of information from point A to point A, point A to point B, sorry, what we do is we do amplification. The device used for amplification is known as an amplifier. What does an amplifier do? It increases the amplitude again. So, let us say after attenuation the amplitude is A dash, we will try to use we will try using amplifier to increase the amplitude again. If the amplitude is increased, hence the strength is also increased. Next, then we studied about amplification was done, then noise was done, range was done, repeater was done, transmitter was done. So, final concept in lesson 3 was a repeater, which is it is a device which has a transmitter and a receiver both. Next concept was bandwidth of signal. Bandwidth of signal is nothing but the frequency range in which any particular type of signal works. There is a dedicated frequency range for TV signals, there is a dedicated frequency range for FM signals, there is a dedicated frequency range for video signals. Everything has a different bandwidth, and hence this concept was been talked in lesson number 4. Then lesson number 5 had bandwidth of transmission medium. And finally, now we are working on lesson number 6, that is propagation of electromagnetic waves. In this propagation of electromagnetic waves, we have already completed ground waves or are in the brisk of completing ground wave, and then we will start with sky wave and space wave. So, let us move on with today's lecture. So, ground wave is the concept we already started with. I told you about surface wave propagation. I told you about surface wave propagation in the last lecture. This all points were being discussed in the last lecture. Just to conclude again, just to iterate again, I will explain the last line again. So, a wave induces current in the ground over which it passes, and it is attenuated as in decrease in the strength. Let me write. So, it is decrease in the So, attenuated as a result of absorption of energy. Who absorbs the energy? The ground absorbs the energy. Absorption of energy by the earth. The attenuation of surface waves increases very rapidly with increase in frequency. This is the concept I told you in the last lecture also. So, it is directly proportional that frequency is directly proportional to attenuation. So, if the frequency gets increased, the attenuation also will get increased. Next is the maximum range of coverage depends on the transmitted power and frequency. This was also told you in the last lecture. What's the range? Range is nothing but the maximum distance a signal can cover from a source to the receiver with sufficient strength. Please make sure sufficient strength is very important for this definition to make sure that the range concept is correct. Let us move on to today's discussion now. So, let us move on to this line. What does the basic concept of ionosphere will also be talked here. The basic crux of ionosphere will be talked here. What is ionosphere, why it is called ionosphere, and so on. So, ground wave is completed. Now, we are moving towards next wave, that is sky wave. As the name suggests, if the wave uses sky as a medium, it is known as a sky wave. What is a space wave? If the wave uses space as the medium, it is known as a space wave. So, let us move on to sky wave now. So, please look here carefully. So, in the frequency range from a few megahertz, just to iterate to you again what is hertz, kilohertz, megahertz and gigahertz. So, 1 kilohertz is equal to 10 to the power 3 hertz, 1 megahertz is equal to 10 to the power 6 hertz, and 1 gigahertz is equal to 10 to the power 9 hertz. Just for your basic requirements. So, let us move on. So, in the frequency range, what is the frequency range? Frequency range means bandwidth only. From a few megahertz up to 30 to 40 megahertz, long distance communication can be achieved by ionospheric reflection of radio waves back towards the earth. What does line mean is, in the concepts of refraction and reflection, even before class 12th or class 11th, we have studied a concept called as total internal reflection. What happens in total internal reflection is, let us say there is a wave, let us say this is the medium. Now, if a wave strikes from here and if it gets reflected and then it again gets reflected, why does it get reflected? Due to the properties, due to the refractive and reflective properties of the surfaces. So, this concept is known as total internal reflection. I will not go into much specification of total internal reflection, because you may have heard it. For easy conceptualization, I will just convey it like this, that if in a medium the wave do not get directed directly, it uses the transparent mediums, not transparent, sorry, it uses the medium's periphery as a reflective or as a refractive properties, uses peripheries reflective or refractive properties to internally reflect, internally as in the wave does not go outside the medium, it is inside only. So, that concept or that phenomena is known as total internal reflection. So, what happens here is, total internal reflection does not happen here carefully, but we can analyze this concept, this first line by that concept only. Let us say this is the ground and we are shooting up a wave like this. So, this radio wave gets reflected back to earth. How does it get reflected? Because of ionospheric reflection. So, let us say this is the area or this is the portion where ionosphere exists. So, what happens is, due to the refractive or reflective properties of this medium, the wave gets reflected back. So, final concept is that there is a source A, there is a source B, we need to pass the information from source A to source B. For passage of information, there should be a medium and there should be such a property so that the wave can transfer from point A to point B. So, if we are shooting up at an angle wave and then it is coming back to, let us say this is the source, this is the receiver, our work is done. So, these are the basic informations how to convey the information from point A to point B. Either you can use ground, either you can use sky, either you can use space. So, in the frequency range from a few megahertz to 30 to 40 megahertz, long distance communication can be achieved by ionospheric reflection of radio waves back towards the earth. Ionospheric reflection of radio waves back towards the earth. This mode of propagation is called as sky wave propagation. So, the mode of propagation of the ground wave was known as surface wave propagation because surface was being used for propagation. This time sky is used, so sky wave propagation is being happening, sky wave propagation. So, if the waves are in sinusoidal, so it is going like this. Let us say this is the brisk where it is reflected and then it goes down like this. So, this mode of propagation is called as sky wave propagation and is used by short wave broadcast services. Short wave broadcast services. So, that local TV channels, local news channels uses short wave propagation, short wave broadcast services, and hence they use sky wave propagation. Next point, the ionosphere is so called because of the presence of a large number of ions or charged particles. This is just a informative point that why does ionosphere is called as ionosphere, because of the presence of large number of ions or charged particles. So, let us say if this is the earth and this is the ionosphere we are talking about. So, you will get many charged particles here. So, that is why it is called as many ions are there, many ions. What are ions? Ions are nothing but charged particles. So, due to the presence of many ions, this is also called as ionosphere. Next point is it extends from a height of 65 approximately. This is for approximate. This sign is for approximately. So, it extends from a height of approximately 65 kilometers to about 400 kilometers above the earth's surface. So, the gap, so the entire range of ionosphere is little high, 65 to 400 kilometers. Next point is ionization occurs due to the absorption of the ultraviolet and another high energy radiation coming from the sun by air molecules. As I already told you before starting skywave, the concept in this slide is only depending upon what is ionosphere, why it is called ionosphere, how it is created and so on. So, just look over this theory part for a little bit, then we will go to one of the questions also. So, ionization occurs due to the absorption of the ultraviolet and another high energy radiations coming from the sun by air molecules. So, energy from the air sun comes to the ionosphere, it gets bulked up, What does it acquire? It acquires the ultraviolet radiation and other high frequency radiations, high energy radiations coming from earth. Who takes up this energy? The molecules, the air molecules residing in the ionosphere range take up these energies and gets ionized. Next point is the ionosphere is further subdivided into several layers, the details of which are given in the table. So, this is the table just for your that point is talking about. Ionosphere is again divided into stratosphere, mesosphere and thermosphere. So, these are the different parts or subdivisions of ionosphere. As you can already see in the last point, we studied that the ionosphere is divided or ranges from 65 kilometers from the earth's surface to 400 kilometers from the earth's surface. So, you can see here that it is also have a subdivision. 65 to 75 kilometers is D, that is part of stratosphere, until 100, that is 75 to 100 kilometers also again is a part of stratosphere. Next is 170 to 190 is a part of mesosphere, and then approximately from 190 or 200 to 400 kilometers is thermosphere. So, this line is also being conceptualized. Next is that the degree of ionization varies with the height, the density of atmosphere decreases with height. This is again a theory concept only, that the degree of ionization varies with height. So, if you keep on increasing, maybe the ionization will decrease or maybe the ionization will increase, and similarly the density of atmosphere decreases with height, that is at lower heights the density is maximum, and as we go above the density keeps on decreasing. So, density is inversely proportional to height. So, this complete slide was based on what is ionosphere, how the ionosphere is being changing, why it is called as ionosphere, what are the subdivisions of ionosphere and so on. Let us move on to some more discussions on sky waves only. So, at great heights the solar radiation is intense, but there are few molecules to be ionized. At greater heights, as in we are going towards the maximum range, that is around 400 kilometers from the earth's surface or 300 kilometers from the earth's surface. So, at greater height the solar radiation is intense, but there are few molecules to be ionized. Close to the earth, even though the molecular concentration is very high, the radiation intensity is low, as it is very clear that maximum intensity is being over very far from the earth's surface, and minimum intensity is because everything gets keep on blocking as the, let us say, ultraviolet radiations come towards the earth, it keeps on blocking, and that is why we have ozone layer. Just to iterate this concept, so minimum intensity is near to the earth's surface, and maximum radiation or maximum energy is towards outer periphery, or 400 kilometers or 500 kilometers from the earth's surface. So close to the earth, even though the molecular concentration is very high, the radiation intensity is low. So that the ionization again low. So if the radiation intensity is low, the molecules cannot grasp up more energy, and hence the ionization is low. If the grasping is more, or the energy consumed by the air molecules are more, then the ionization will be more. So ionization is again low. Next is, however, at some intermediate height there occurs a peak of ionization density. So if I iterate to you using a diagram here, let us say this is the ground, let us say this is the portion which is let me make it much smaller. Let us say this line, this diagram is not up to scale. Let us say this is at approximately 65 kilometers from the earth's surface, and let us say this is 400 kilometers, approximately 400 kilometers from the earth's surface, approximately 400 kilometers from the earth's surface. So what does these three lines say is that the intensity ionization is not maximum even here, not even maximum here, not maximum. Let me write it as not n max, not maximum, not maximum. It is saying that in this intermediate position, the ionization is maximum. Ionization is maximum. The reason for not maximum here is being told here, the reason for not maximum is being told here. And then finally, so if I make a typical plot, the plot cannot be accurate also, but it can be something like this, that the intensity is low in this position and it is max in this position. You can view it like this. So this is ionization from this part, and this is the distance. So ionization is maximum in the middle portion, and it is smaller in the other portions. Final point for this lecture: the ionospheric layer acts as a reflector for a certain range of frequencies, that is 3 to 30 megahertz. So this is the ionospheric layer which acts as a reflector. What is the use of reflector? What will be the conceptualized for us? Reflector will be used for passage of information from point A to point B using reflection. The ionospheric layer acts as a reflector for a certain range of frequencies. So if I use a signal which has a frequency of 3 to 30 megahertz, then it can be used as a reflector. Electromagnetic waves of frequencies higher than 30 megahertz penetrate the ionosphere and escape. So these higher cannot be used as a sky wave. These phenomena are shown in figure this is the phenomena being showed here, and the phenomena of bending of EM waves so that they are diverted towards the earth is similar to total internal reflection in optics. So for this lecture, let me stop it here only. I will start with again a detailed explanation of the last point in the next lecture. For now, thank you.